Hello everyone, my name is Mehmet Emre Endar. I'm a freshman industrial engineering student at Bilkent University from PHYS101 section 7. In this experiment, I examined how the kinetic friction coefficient behaves under two changing conditions: the distance a block slides down an incline and the angle of the incline itself. My goal was to evaluate whether kinetic friction coefficient depends on external variables or whether it behaves purely as a property of surfaces in contact. In this video, I will talk you through the theoretical background, the equations I used, the experimental steps, and the analysis of data. To understand the motion, let's start with the free body diagram of a block on an incline. The gravitational force splits into two components, mg sin theta, which pulls the block down, and mg cos theta, which acts perpendicular to the surface. The kinetic friction force acts upward along the incline and opposes the motion. Using the Newton's second law, the net force becomes this. By rearranging the earlier expression, I calculated the friction coefficient using this equation. The experiment consisted of two main sections. In the first section, the incline was fixed, while three different distances were tested: 0.60 meters, 0.75 meters, and 0.97 meters. In the second section, the distance was fixed at 0.75 meters, and the incline angle was changed to 25, 30, and 35 degrees. Each condition was repeated 3 times for more accurate results, and this consistent approach allowed for more reliable calculations among all trials. Here are some demonstrations showing different trial conditions, such as different distances and different incline angles. In the distance variation section, the values of friction coefficient range from 0.345 to 0.363. Although the distances differed noticeably, the friction coefficient remained almost constant. The best fit line for friction coefficient versus distance had a slope extremely close to zero. This indicates that friction coefficient is not affected by how far the block travels, which agrees with theoretical expectations. In the angle variation section, kinetic friction coefficient ranged from 0.341 to 0.362, again showing minimal variation. The best fit line for friction coefficient versus angle also produced a slope extremely close to zero, demonstrating that our kinetic friction coefficient does not depend on the incline angle. As for the errors, the small variations in friction coefficients is observed throughout the experiment were primarily due to normal measurement limitations. Human reaction time during stopwatch usage can create noticeable timing errors, especially for shorter distances. Additionally, slight unintentional pushes during release may cause a tiny initial velocity, altering the measured time. Despite these factors, the data remained highly consistent, showing that the experiment was reliable. In conclusion, this experiment strongly supports the theoretical model of kinetic friction. Across all 6 different test conditions, the friction coefficient stayed tightly grouped in a narrow range, confirming that it is determined by the materials in contact rather than by distance or incline angle. The zero slopes in both of the graphs clearly demonstrates that friction coefficient behaves as an intrinsic property of the surfaces. That's it for me. Thank you for watching.